Welcome to section 1.8, where we will talk about the derivative as a rate of change. So the most important thing to start this off is I love abbreviations, okay? So I'm going to abbreviate rate of change as ROC very, very frequently. So have that noted in your notes. Goodness. So the average rate of change is average slope. Rate of change is slope. So average rate of change is average slope. So this formula I'm about to give you for the average rate of change is just a slope formula. Okay, so let's start with that. The average rate of change, ROC, from A to B is, and that does not say TOB, that is to B. There's definitely a space there, is going to be f of B minus f of A. So that's the rise over the run, the difference between the inputs, B minus A. Slope formula, rise over run. All right. And that's what we're going to be using in this first video. Like so. This is something you will need to know. This will not be given on a quiz, so know this. It'd be great if you just know everything I ever talk about, but I think that's a little idealistic. I have forgotten 90%. 90% is a very low number. 90% of what I've learned in my college experience. All right, so let's kind of see what this looks like in a little picture, right? So if I have some kind of graph over here, and I don't know, maybe this is A down here, maybe this is B right here. The average rate of change, right? It's just the rise over run over here, which is kind of like this blue line that goes through both of them. Like so. So that's the average rate of change. In this case, the average rate of change is very close in slope to the actual rate of change. That will not always be the case, right? The blue is the average rate of change. So let's do a problem, shall we? Example 1. For f of x equals x squared plus x, calculate that's supposed to be a t, the average rate of change of f over the following intervals. All right. Part A is going to be the interval x going from 1 to 2. So we'll find the function value at 2, the function value at 1, take the difference, divide by the x's. We're going to be using this formula right here. And it's a good idea to start by writing down the formula. Okay? So it's going to be f of 2 minus f of 1 divided by 2 minus 1. Rise over run, slope. Average rate of change is slope. And you're going to see where we're going soon, because what else is slope? Slope is derivative. Derivative is slope. Okay, so little teaser for video 2. All right, 1.8b. I need to be consistent on that. Anyway, so now we just plug things in. So f of 2 is what happens when we plug in 2 into here. We plug in 2, we're going to get 2 squared plus 2 minus f of 1. What happens when we plug in 1? Now be very, very careful to include these. I love parentheses. We need these. Otherwise, you're going to get the wrong answer. Or you can go off to the side and find f of 2 and f of 1 on the side, and then that would work as well. So we're at 1 squared plus 1, all divided by 2 minus 1. Well, that's just 1. Now we just simplify. This becomes 4 plus 2 minus 2 is what's inside the parentheses, divided by 1. Don't need to write the divided by 1. And it should just be 4. So on average, over this interval, this function's growing by 4 for every increase in x. That's the approximate slope of this function. We can do more of these. We can do as many of these as we want. So let's just do another one. Part B, what about the interval from x goes from 1 to 1.1? It's going to be very similar. All right. F of the second one minus f of the first one minus the second one, or divided by the second one minus the first one. We'll just keep plugging things in just like before. 1.1 squared plus 1.1 minus 1 squared plus 1. Just evaluating things in the function, plugging things in. Now the bottom simplifies to 0.1, which is 1/10. Remember, dividing by 1/10 is the same as multiplying by the reciprocal, multiplying by 10. So over here, when we really simplify this out, where that's going to be 1.21. 1.21 plus 1.1 minus 2 as before. And again, dividing by that 0.1 is the same as multiplying by 10. We'll have 10 times the inside simplifies to what? 2.31 or 0.31 once we subtract the 2. Multiply that by 10, just moves the decimal over, and we get 3.1. So over the big interval, the average rate of change was 4. Over the small interval, the average rate of change is 3.1. All right, and that's kind of how to approach these ones. Good luck. Go get started on these problems, and when you get back, you're going to be excited to find out instantaneous rate of change. So we got that to look forward to.